Hi, this is Michael Emmerine, and this session will be discussing how decouplers work. What does our decoupler actually do? We have a high resistance to cathodic protection current. That's the DC current. We don't touch the cathodic protection current. We have a low resistance in our decouplers to frequencies that are 50 and 60 hertz and other higher signals to allow those frequencies to go through our device to the grounding system. So induced AC and AC faults, and as you'll find out, lightning, will go through our device safely, collapse that AC voltage, and run it through our device to the grounding system. That is, as you just heard, a very safe feature of our device for the technicians working on the system and for any other types of electrical equipment that might be on the pipeline system. So it allows that AC, induced AC, to go through our device to the grounding system. And what about lightning or AC faults? It also allows lightning to pass through the decoupler to the ground for safety. Since the Dairyland decoupler is not touching the DC current, that's the cathodic protection current, and it does allow that induced AC or an AC fault or a lightning event to pass through the Dairyland decoupler to the grounding system, that's all safety. Again, we're not touching that CP current. That means that a technician would see an optimization of their CP system because we're not touching that DC current. The induced AC that is out there on the system is mitigated, and that is what the company most likely is after, is to mitigate any AC that's appearing on their system. It's protecting the technicians as well as electrical equipment. That's the safety first idea that Dairyland has that is also being looked at by a pipeline company to be safe with the technicians and safe for any electrical equipment. This is a pretty good example of what's existing in the real world. The corridors being shared by a pipeline company as well as a high voltage power line. So if the pipeline exists, doesn't matter what came first, is it the pipeline or the power lines, it doesn't matter. They're all in the same corridor. And this pipeline has actually got a couple of features that is very prominent. There's a rectifier that's supplying cathodic protection to an anode bed, and that is protecting the pipeline. That's the engineering feature that's supplying the cathodic protection, the DC current to the pipeline. But the company has decided that there should be some mitigation of AC, and that's normal. They will attach or lay down a copper or a zinc ribbon, and that's draining off, you might say, any AC that's existing on the pipeline. But there's a problem in that, in the fact that not only is the anode bed, the cathodic protection current being supplied from the rectifier to the anode bed, it's supposed to protect just the pipeline, but because of this structure and the different metals that are now in the earth, the cathodic protection is now trying to be supplied to everything that's there, the pipeline and the zinc or copper ribbon that's laid down. So the efficiency of that system is no longer there. It can't protect everything efficiently. There's where the Dairyland decoupler comes in play. So you see those green devices on either side of the rectifier. That is a pedestal, and inside of that is a decoupler. We allow that AC to go through our device to the grounding system by attaching a wire from the pipeline to the negative lug of the decoupler, and then the positive lug would go to the grounding system. So what's happening is that AC is being mitigated through our decoupler to that grounding system safely, and it allows the cathodic protection, the DC current, to stay just where it was designed to stay, which is on that pipeline. So the technician and the pipeline company would see an optimization of their CP current.